really excited to get this next module started, and I'm really actually proud to be featuring Daniel Butay, and he's going to be talking to us a lot about like what's going on with clean energy. You know, what are recommendations that homeowners should be thinking about when they're doing clean energy improvements to their home. And let's just dive right in. So please introduce yourself and tell us a little bit about what you do.
Yeah, so my name is Dan, and I'm an energy consultant. I've been in the residential services space for going on 15 years at this point. My background is electrical engineering, and I really like educating homeowners about the things that we're going to be talking about to empower them about making good decisions about heating, cooling, and powering their house.
That's awesome. So what are you kind of seeing in the trends that people are kind of, you know, there's been a lot of incentives with clean energy upgrades to your home. There's been a lot of rebates coming and going. So what are you seeing right now in the marketplace that people are kind of like going after and making big improvements in their homes?
Sure. So anybody that is looking to switch over to heat pumps, they're typically trying to get away from how they're currently heating their house. And the major driver, I would say, is the cost. In New England, it can be very challenging to heat a house. And so people are trying to get away from things like oil, natural gas, propane, electric resistance heating. And heat pumps is a really good way to look at an alternative source because it is electric. And so that's sort of tied in hand with solar, because if you can get cheaper electricity, then you could potentially be heating and cooling and powering your house at a much lower rate than typically. I think a lot of people have questions about rebates, incentives, federal, state, mass save, and there's a lot of information out there to parse through. So it's really important that they understand what they're actually eligible for and how they can benefit from all these different incentives when they're making that switch. So I think a lot of the questions comes from what's available, what's out there, and how they can get lower cost electricity as well as lower cost heating and cooling.
Absolutely. So when people are kind of going through the decision-making process, where do you kind of recommend they begin? Like, where does this whole journey start for them?
Yeah, absolutely. I think a great place to start is figuring out where they currently are. Right? Because if you're trying to figure out how to get to one place, it's a good place to understand where you're starting first. And so when people are thinking about solar, a great place to start is the electric bill. Trying to figure out how much they're using per year. Most electric bills have their 12-month usage right on the second page, so they can figure out how much they're using and also what they're paying per kilowatt hour.
Okay.
So a very basic bit of math that I do with a lot of homeowners is figuring out how much they're paying for a certain month and just dividing that how many kilowatt hours they used in that month, and you have a per kilowatt hour rate. Most homeowners that are paying National Grid or Eversource for their electricity find themselves anywhere between 30 to 38 cents per kilowatt hour, depending on the supplier of electricity. People who live in municipal towns are likely paying much less, but the math formula works exactly the same. Just figure out how much your bill is, divide that by how many kilowatt hours you're using, and then you have your rate per kilowatt hour, which is really important to calculate things like how much you're going to be saving when you're switching over to electricity or heat pumps to heat your house. So I think that's a great place to start, is figuring out, at least from an electricity standpoint, how much you're using, what your rate per kilowatt hour is. And then if you are, let's say, using oil, figuring out what your yearly cost looks like. And typically people are kind of looking back over time at what their oil invoices have been for a year. Typically the cost is anywhere between $1,500 to $2,500 a year when it comes to oil, depending on the size of the house. Folks that are buying natural gas can look at their natural gas bills and figure out how much they're using on a yearly basis. A lot of people that are using natural gas for hot water have that sort of baseline amount of usage that they're using throughout the year. In the summertime, obviously, you're not using it for heating purposes. You're just looking at your hot water. So it's a good idea to start with a basic understanding of how much you're spending and what your expenditure looks like for electricity and also for heating the house. And that goes for propane, that goes for electric resistance heating as well.
So this is really great information, and I love how you broke that down very simply. And I mean, it's very practical, right? It's like, you know, you want to look at your finances and kind of figure out where all your money's going, especially, you know, at the peak of the winter months when it gets really, really cold out and you're running your heat a lot more to stay warm, right? And stay comfortable. And then, of course, in the summer for the heating, the cooling. So now that they've kind of done the preliminary homework, they kind of know where the utilities are going. They're really starting to see, oh yeah, my oil costs are really high, or maybe my natural gas is really high. Why do people start looking at systems like heat pumps and solar and battery storage? Where does that come into play for many homeowners?
Really, I think they're just looking for an alternative source of power, an alternative source of heating and cooling. And I think folks have a lot of questions about how they can improve the efficiency of these heating and cooling aspects of their house. And so, when they're looking at things like heat pumps, really the core question is, can I heat my house at a cheaper cost with heat pumps than it would be if I were using what I'm familiar with now, which is oil, gas, propane, electric resistance? And a lot of times when you're doing the calculations, heat pumps will be cheaper across the board when you're looking at all those different things. Now, natural gas historically, it was pretty close when we did the math, but with the natural gas prices going up so much that they've done in the last couple of years, not only is it a wash for a lot of those people, but they can actually be saving money. And so when these homeowners are trying to decide where to invest their money, it's really important to understand the return. And so when I'm having these conversations, there is a little bit of math that we need to do to figure out, well, how much you're saving, what is the return of investment, and is it really worth the investment? Because that's really what it is. It's an investment of not just time, energy, but also funds. And the most successful homeowners, I would say, are very forward thinking and are not very short-sighted. They're looking at what they're going to be saving today, which is great, but also what they're going to be saving over time. And I think what people need to understand is how the savings actually compound over time when you can get some more control over things like your electricity costs. So that's really where that's kind of a launching point to talking about some of these things and these alternative sources. So people are just looking to do something different. There's that saying of, if it isn't broken, don't fix it. But where people look at it as broken these days is the rising cost of heating and cooling and powering their houses.
I love that. And I think it makes a lot of sense when we're kind of diving in and trying to explore ways to combine systems to maximize savings, right? And there's a lot of different ways that you can kind of structure that. And we'll kind of talk about that a little bit more today. Kind of diving in a little bit more about the heat pumps. I mean, I didn't know a lot about heat pumps and I'm still learning about them, but there's not just one type of, there's a variety of different heat pumps, I'm understanding, right?
Yeah, absolutely. So I think when people hear heat pumps, they think about, really the traditional ductless mini split. I think that is where a lot of people's minds go to. But there's a lot of people don't realize that there's actually different versions of mini splits as well. You have your standard high wall unit. You can also have floor units. You can have ceiling cassettes. And something that is really gaining popularity, I would say, is a ducted heat pump. So a lot of people who have existing ductwork in their house don't necessarily want to have these mini splits all over the place. And so what people are realizing is that they can actually replace a furnace with a fully ducted heat pump system that's going to be able to provide heating and cooling throughout the entire year. So a lot of these people actually have just heating coming out of their ductwork, but when you replace a furnace with a heat pump, you can actually get both heating and cooling through that same ductwork. Now, there might be some modifying, some balance, some insulation that needs to be done with that ductwork to make sure that it's working properly. But as long as that's done really well, you can get sort of like a 2-in-1 with your existing ductwork. And not only are there different types of mini splits, but there's also different types of heat pumps. You have water to air heat pumps, for example. I would say the most common ones are air to air heat pumps. You also have geothermal heat pumps, where you're taking the natural heat that you get from the earth and you're actually moving that over to air, or perhaps a hot water system as well. So there's a lot of different types of ways to address a house with a heat pump, and it's important for the homeowner to figure out what the right fit is.
Got you. So this is really interesting to me, because I didn't understand that you can use those vented systems and then combine them with air conditioning and heating on there, which just sounds like it's something that's very practical.
Yeah.
But in addition to that as well, when you guys are actually doing your initial surveys, your guys are actually doing some pretty extensive research on the house to actually make sure that you have the right system for that specific home, right? So walk me through what that kind of looks like, and like what you're actually doing when you're actually meeting with homeowners to determine whether or not it's going to make sense for their home.
Sure. So just like with solar, it's important to understand how much roof space we have and how much electricity the home needs so that we can properly size the system. The same goes when it comes to heat pumps. It's all about right sizing the system. There are Downsides to oversizing a system, the system is going to short cycle, it's going to be running way more often than it should, and in the summertime, it might not be running long enough to really dehumidify a house. And then obviously there's downsides to undersizing a system. It's just going to be working really hard. It's going to be having a hard time keeping up with the demand that the house needs. And so a great place to start, and a place where everybody should start, is doing what's called a manual J calculation of their house, which really determines the total heating and cooling demand for the entire house, not just for the summertime or just for the wintertime, but really for the whole year. And when you are doing a mini split system, it's about sizing the heat pump or the mini split for the demand for that specific room. Because when we're doing a mini split system, it's really a multi-zone type of situation where we're addressing just the rooms, and really that's what adds to the efficiency. So what does a manual J really entail? It's going through the different condition spaces of a homeowner's house and measuring things like the height, the width, the measurements of the windows, how many windows they have, what direction those windows are facing. And so there's a lot of different ways to do it. You can do it freehand, or there's programs as well that you can use with, like, let's say an iPad and a LiDAR scan, which is what we do, to really determine and dial in. Because believe it or not, the biggest mistake homeowners can make when they're switching over to heat pumps or installing heat pumps or really any HVAC system is wrong sizing the system for the house. With traditional fossil fuel systems like oil or natural gas, typically those furnaces are way oversized for the house, and that's okay because they can really pump out a lot of heat and get to temperature, and there isn't as much modulation. But with cold climate heat pump technology these days, these heat pumps are very sophisticated. They're inverter driven, and they can modulate the electricity consumption to get that very specific temperature in the room. And really, you need to dial in the sizing at that point. And so what I'm doing with homeowners is I'm able to scan their entire house. Depending on the size of the house, it could take anywhere between 30 minutes to upwards of 2 hours if it's a very large house. But having this information up front means that we know how to size the system appropriately, and the homeowner has the peace of mind knowing that they're using their funds efficiently for this project, and they don't feel as though they're being overcharged or oversold because of the system being way too big or way too small. It's really about finding the right size and taking a Goldilocks approach to their home.
How are you guys doing this? What tools are you guys using to make this happen so you guys could show the homeowners what's the best system for their home?
Sure. So we decide to be very data-driven through technology. And so we use iPads and a program called Conduit, which there's different types of programs that are out there that does this, and contractors do this depending on the type of program they want to do. And there's generally a rule of thumb when it comes to sizing systems, and some contractors will look and just say, okay, well, this is an 1,800 square foot house. We need roughly 1 ton of heating per 600 square feet of living space, and so you need a 3-ton system. But it isn't as simple as that. This program, I can actually tell it what type of insulation is in the walls, whether the basement is insulated or not, whether this is a knee wall, if it's adjacent to a garage. And so it's very data driven based off of someone's home, and every house is different. Every house is like a fingerprint. Everybody is different, and so really it allows me to dial in the exact sizing depending on the situation. And so what we do is we do a LiDAR scan of the conditioned spaces within the home, whether that's a basement or just a bonus room above a garage. I'm looking at the entire house. And depending on what I'm trying to address, this program can then calculate the total demand of all the different spaces that I'm trying to address, down to the BTU. So if, for example, a living room needs 8,200 BTU, then I know that I can install, let's say, a 9,000 BTU unit for that room. So it's important that I'm not too big or not too small for not just the whole house, but also the spaces that I'm trying to address.
That's great. Yeah, let's dive into the technology to see what it looks like.
Great.
Awesome, guys. So we're really excited to dive into the next part of this, which is diving into the tools that you guys use to really do a proper diagnostic on the home and figure out whether or not you have the right sizing system for the home. So what are we looking at here? Walk me through what the platform is.
So this platform does a really good job at showing and directing these reports to the audience that is really necessary to have this information. So this is a full diagnostic report that we would put together and share with the homeowner as far as what the actual demand is for the entire house. And it goes to room by room. So here, this shows the total square footage of the house, 1477, shows the volume, and then also shows you the total heating and cooling demand for the entire house. So for this particular home, which is 1,477 square feet, it needs 46,764 BTU of heating. And we're in New England, so it's much easier to cool a house down than it is to heat a house up. And so we are actually sizing the system based off of the heating demand of the entire house. If we were living in Arizona, then obviously we'd be looking at the cooling demand, and you can see that the cooling demand is much lower for this home. So needing 46,764, if we were doing one big central system, then we know that we need roughly like 4 tons, 48,000 BTU by room. So for example, this kitchen needs, and I'm looking at this column right here, 7,584 BTU of heating. And then we can look at the bathrooms. Bathrooms are typically much lower in demand. Family room, living room. We can really look at the different spaces within a house and figure out what the demand is so that we can right size the unit for that space. And what we like about this program as well is that it allows us to mark up the floor plan of the house. So as I'm doing my 3D scan, it's also able to export a floor plan of the entire home as well, so that I can show the homeowner exactly where the units are going to go, what units we're installing in those spaces, and what demand we're actually trying to expect that unit to address. And so, for example, we have a 12,000 BTU mini split in this room, which is that rectangle right there, because we're expecting it to cover roughly 9,500 or so BTU of demand from this bathroom and also the kitchen. Not only can I show where the indoor units are going to go, but I can also show where the outdoor units are going to go and add notes like the outdoor units are going to go underneath a porch. This really sets good expectations for the homeowner as far as where things are going to go. And that's that first floor there. This house happens to have 2 different types of systems. We're actually adding ductwork to the second floor. So it's actually a great combination of mini splits on the first floor and a ducted system on the second floor. And in this particular case, I can actually show where the outdoor unit is going to go as well as where the indoor unit is going to go. In this particular case, we're adding ductwork, so we're adding supplies and returns appropriately in each of these spaces to meet the overall demand. So for example, this second floor needs roughly 20,000 BTU of heating, and so we went with a 2-ton system. This happens to be a Mitsubishi system that we're installing for this home, and you can see the different zones there to kind of show what the demand is. And again, I'm going back to the demand and really leaning into what that space needs and sizing it appropriately for that space. What I also really like about this, and homeowners love this, is that I can add visualizations using augmented reality. So I can actually take a picture of anywhere in the house, and this program allows me to choose different types of units, and I can show the homeowner what it's going to look like in that space. And so in this particular case, I can show them that what a 9,000 BTU mini split is going to look like in their living room. And aesthetically, this is really important for a lot of homeowners. I can actually position it over here. So I'm actually walking through this house with the homeowner and talking about where things are going to go and where they would prefer. And besides this, we also have to consider airflow. So in this particular case, it's actually pointed towards the entry of the house where I'm not actually putting a unit. So it really helps me consider and explain not just the sizing of the unit, but also the placement of the unit and how important that is in addressing a specific place. So that's an example of a living room. This is another example of a family room where I'm actually putting it above a slider door. And this is a kitchen as well. And some of these notes are actually also meant for the installers. So I can also drop an install report that is meant for my project team so that they understand how we're running the line set. Now, with mini splits, one of the trickiest things to sort of figure out is how do we get from the outdoor unit to the indoor unit? And a lot of homeowners are also curious about what these would look like on the outside. So not only am I able to give them visual representations of what it would look like on the inside, I'm also able to give them representations of what it would look like from the outside. So this program, for example, that have preloaded units. In this case, it's Mitsubishi, so I can show them what that outdoor unit would look like. I can show them how it would be bracketed onto the foundation, or in this particular case, it's actually on a rack. And we felt like this was a good location for the units as they're sheltered underneath the porch. And I can kind of show them, I can show my installers how we're going to be running the line set from that outdoor unit to the indoor unit. So for example, I have a visual representation of the outdoor unit and how we're going to be running that to the unit that's in the family room. So really it helps connect a lot of the dots from where the outdoor unit is to the indoor unit, what it's going to look like, and also why we size things the certain way that we did in the house. And so it's really just a great overall summary, and I can export this as a PDF, email that to the homeowner. And what this does is it really prevents a lot of the surprises that can typically happen at the day of the installation. You know, if the unit isn't going to go a specific place where they were kind of expecting it, there's typically reasons behind that. And so these reports really prevent a lot of the surprises that can happen over time. And if you think about it, not every contractors are doing this. So you could be going into a situation as a homeowner completely blind as far as where things are going to go and how things are going to look. And so having this technology on our hands really positions us to have a very, very good homeowner and customer experience overall.